Hope you guys are ready for a non-technical talk. We'll try not to bore you, but maybe you're thinking about starting a company, or maybe you'd just like to understand how do investors think about these ecosystems, and why is RISC-V one of the ecosystems that I think will attract more money over time and will help it thrive. So I'll give you a little bit of a perspective. For me, investing in SiFive and working on RISC-V was a little bit like coming home. I studied computer architecture at Stanford. I built systems with custom chips for almost 20 years, and it really resonated with me when Jönsep and Christian and Andrew first talked to me about what they were trying to do. I thought it was super useful for people that still build those kinds of systems, and so I was immediately excited to go work with them. When I look back, the evolution of the RISC-V ecosystem, we were confident in, but honestly has exceeded all of our expectations. And so I thought, we'll have sort of two parts of the talk, a little bit about how investors think, a little bit of a history lesson of how SiFive actually attracted some money and how we thought about it. And then maybe a couple of thoughts on where we think the opportunities are going forward. So, a little bit about us. We like to invest very early and build for the long term. We're kind of an old firm, and we like to do things the old school way, partnering with entrepreneurs. Most recently, we were there at the founding, obviously, of SiFive, of Pure Storage, of Snowflake. All companies started out of our office, and we've been doing that for a long time. So my partner Tench is still on NVIDIA's board, and it's been 33 years or so. So that's what we like to do. Big markets, really hard technical problems, and we provide help in building the companies and providing long-term capital. So when you look at sort of B2B investing, and strategy, everything's a 2x2. So let me take you in the mind, the not so sophisticated mind of an investor as you think about this. There are really kind of, four categories when you look at adoption risk. So if I have something, will somebody buy it? And technical risk. How hard is it to build? When it's low adoption risk and low technical risk, it's a service business, and that's what it is, and probably not a good idea to attract venture capital. If you're building Facebook or you're building Twitter, you can build it. The question is, will anybody care? And that's kind of on the lower right? And you can fix everything else later. If you're building Google, it's really hard to build, and you don't know if anybody cares. So that'll be in the upper right. And I would say, all the rocket startups and space startups are kind of in that category as well. And most of B2B is on the upper left. It's a huge market. You know who you're competing against. If you build something that is better, cheaper, or both, you can succeed. Now, to be honest, I think RISC-V was sort of between the upper left and the upper right, because you didn't really know how many people cared about open standards and open source. But for the vast majority of companies in B2B, they're in the upper left, and that's kind of what people invest in. So then how did SiFive actually attract venture money? And it's kind of interesting to see the last 4 to 5 years, because I would say that when SiFive got started and RISC-V got started, investing in semiconductors was not very popular. It's still not the most popular, but you have a plethora of AI chips that attracted a lot of money in the last couple of years that I think are part of that trend. But I think grab Jönsep or Krista over a beer, and they'll tell you it wasn't all that easy. Now, they had a very compelling vision, and one of the fun things I thought I would do is I copy and pasted some of the original pitch slides from SiFive into this presentation, and we can see sort of what's still true and maybe how they presented their idea. The one thing I'll say beforehand, and this is kind of because so many of these other startups attracted so much money. One of the things that got us comfortable and really excited is, how do you find product market fit in something that's very new, where there's a community component and a technology component. So part of the pitch was, hey, for the first $5 million that we invest in the company, We actually licensed our first CPU, with a runway that we had for that $5 million, and we taped out 2 chips. Now we had, at that time I was actually still acting CEO, so before Naveed joined, I was both the investor and the CEO. But we really wanted to prove out some of those risks that you can't really mitigate later, to prove that anybody cares about the kinds of stuff that we were building. So when you approach a VC, if you can get some of the risks addressed early on with little money, they like that a lot. I can tell you. So let's look at some of the pitch. And really it started with the tagline that our best marketer at the time came up with, and that was Andrew Waterman. Not usually known for his marketing work, but I asked him, well, why did you start SiFive? He's like, well, because Moore's Law only ends once. And that was still one of my favorite lines. But essentially, it was about open source and mass customization. We felt like there was a supply problem, there was a new demand coming up, and there were sort of existing players and an industry structure that wasn't well suited for addressing these challenges. So the supply problem was, the economic end, I'll call it, of Moore's Law. It gets more and more expensive. We just heard about that in the first keynote as well. And so really, it's not just the manufacturing cost, it's also the design cost in these new nodes. And you have kind of this exploding complexity, so fewer and fewer designs get done. You have to cram in more and more features, which makes it less and less attractive for some of the new use cases that we saw coming up. And those are basically summarized as what is now known as domain-specific architectures, but IoT applications, cloud applications, maybe even things linked to 5G going forward. The exciting thing for us was, hey, there's actually demand to build a whole set of new types of computers that have different optimizations than the stuff that we built before. And through that, it became pretty clear early on that this had to be a different kind of business model. Right? The semiconductor industry was always about the killer socket. And there became fewer and fewer killer socket as defined by I can go to the latest manufacturing node early, and if I do that, I'll sell a gazillion chips at high gross margin, right? We do think there are certain players that were crippling, innovation in the space. Not because they were bad people, just because their business model demanded a certain amount of upfront investment, a certain amount of time, and that wasn't well set up for these kinds of new sources of demand where forecasting your demand was a lot harder, and so experimentation at lower cost and higher speed was really critical in those places. So that was sort of the macro thesis. It's still true, I think. I think these are cyclical trends that are really kind of like 20-year trends. These are not something that will change next year. So then in terms of enabling technologies, obviously it was about RISC-V. And we knew that we couldn't go at it alone. There was no way to do that. This original pitch and the original funding was actually done, I think, pre the official start of the RISC-V Foundation. And then, SiFive providing the kind of agile design flow, really the leading kind of thought behind the company still is if we can have the cloud model applied to how you build chips, that will revolutionize the industry, that will allow everybody to go design, whether it's academia or systems companies that want to build customized systems at a reasonable cost and high speed. When you look at the market, we took sort of the FPGA set of customers as a proxy. There's sort of 30,000 customers that buy non-trivial amounts of FPGAs. They do it to customize. A lot of the big players are vertically integrating. As it turns out now, when as part of the, being the chairman of the board of SiFive, you realize that even in the players that are customizing, if you have a verified core that is high performance and fully verified, even those players might want to not do everything themselves. But you can think about that market in a way of serving even the long tail, at totally different economics than what was possible beforehand. And that was really compelling, so that you don't just need to go and say, okay, I need to either win one of those, I need to win one of those 10 sockets to have a company or not. So what? So what does that mean going forward? So like I said, today we have, through Patterson's and Hennessy's Turing Award speech, we have a great way of talking about these things. They're domain-specific architectures. It's the end of general-purpose computing. And if you can customize at low cost, domain-specific architectures will rule. It's a really, really hard problem. We heard about verification. We heard about security. And we are maybe 20% of the way through. But I think it's a solvable problem at this point, and is powered by a business model, both from the consumer side, people that want to use this stuff, and a producer side that really works. And so that's what makes us so confident, not just in the fact that, yes, there will be domain-specific architectures, but RISC-V will be at the basis of driving this. There are lots and lots of big opportunities. I won't list them all. In fact, one of the reasons I'm a VC is because I'm not smart enough to figure out where the opportunities are, but I can sort of test whether they might work or not. But a few things I'll say. I mean, there's the new sources of demand are clearly driving, they're the early adopters, right? It's IoT, it's 5G, it's cloud, it's the edge intelligence, it's whatever you want to call it. They all need free and open architectures. They clearly need enhanced security. I was very interested in the last talk. It's all about hardware-software co-design to unlock value for the end customer, which is the person who's trying to sell the service or the system, right? And so, the way to think about this, I think, is a very obvious stat, which the CPU licensing market is 1.5 billion, and the chip market is 100 times bigger, right? So I'm very interested in sort of how RISC-V powers all of this, and then how we take it forward with the CHIPS Alliance that we heard about this morning. I think from a business opportunity point of view, there are just huge opportunities in those spaces. I wanted to give a little bit of an analogy that I think we and other investors will use as we sort of think about this. And this has to do with how I think the business model evolves going forward. So you now have open standards, you can be more agile, you can certainly reduce the cost, and most importantly for most of SiFive's customers, the time to market for shipping a compelling product. Because you are able to experiment at much lower cost, you can move faster. When this happened in software, really with the move to cloud, it bred a whole set of new vertically focused companies that go a little bit further up the stack. They basically say, okay, I can build a messaging system designed for certain ways of working, as in Slack, a productivity system that feels very different in terms of maybe you don't use Project or you don't use Excel, like Smartsheet was a public company. You can build vertically specific software stacks, ranging from CRM to other parts of your back office. Viva is a public company worth 25 billion. Velocity, one of our companies, is doing that. And it's all enabled by the ability to experiment at much faster, reduce upfront cost, but don't give up anything in terms of scaling, right? Your company, your service. This is what the cloud did for software companies. I think a similar or analogous thing can happen on the chip side for systems companies. I foresee, subsystem and system companies that build their own chips, where the main value is actually integrating the software and the hardware stack completely to address something that is very high value for that end customer in that vertical or in that use case, right? This is what the cloud did for software, and I think RISC-V and the CHIPS Alliance and all the open tools that come together can do that for hardware, and that's why I think the real prize over time is actually the 100 times bigger chip market versus just I can use this CPU or that CPU. I think the implications are much bigger. So, in sum, I think when I look at this in the rapid evolution, we are 4 to 5 years into a 20 or 25 year technology cycle that I think will redefine how people build systems. A lot of those systems, from their end customer point of view, will be consumed as software capabilities, but they will be powered by custom hardware. Certainly everything outside the data center that's embedded will work that way. But even in the data center, there's lots of opportunities because we now have a software system on top that can rev hardware relatively quickly. So I think RISC-V absolutely is the leader in this. There should be no reason that the future of computing shouldn't be powered by RISC-V, even though it's still early in the journey. It's up to us in terms of a community to make sure that we stay on that vision and make it happen. And I'm really excited about the kinds of new chip and systems companies that will be built with this new ecosystem. I think you look at market size, which is always a great predictor of success for a VC. This is one of the largest markets in tech, not just hardware, but in tech. And if we bring new business models to this market through open source and mass customizations, through hardware-software integration and co-design, it will be a growing industry and it will be a highly profitable industry. So with that, let me conclude here. Looks like I have a couple minutes left. If there's questions, otherwise you can just grab me after the session.
Thanks. I find your final comment about growing industry, and you started earlier in the talk about at the time of SiFive's founding, it was a $350 million TAM or so, or $1 billion, excuse me. Can you just comment about expectations or your thoughts on not the fact that the TAM might be growing, but more the fact that, or thoughts on whether the techniques we're talking about here actually drive a faster expansion of the growth of that TAM?
Yeah, it's a great question. So, that will depend, how fast the TAM grows really depends on what applications succeed first. That's very hard to predict. Now, if one of the reasons, for example, that Juniper and Cisco were successful, two companies that I know a lot about, is because they were able to bundle hardware and software and sell the whole thing for a much higher profit than buying the piece parts, because there was value to the end customer in terms of using it. And if we have more of those companies come to front, then of course, that will make the TAM grow faster. And it'll also change the TAM, right? We'll see how we count those. Do we count those as chip companies? Do we count those as systems companies? Right? I think vertical integration, mass customization for systems and subsystems powered by RISC-V is how we'll change the landscape. These are still early days. Like I said, this is a 25-year cyclical trend, and we're still in the first innings. The interesting thing about adoption is you can predict who's going to win relatively early on if you look at the slope of the curve. I can't really see folks, so I think that there was a question here.
I have another question. I saw a picture from your slides that it seems that SiFive want to serve the long tail market. As I know, for example, Alibaba or Amazon, when they serve the long tail market, they actually have a long tail suppliers, especially for Alibaba. So what's the plan of SiFive to acquire a long tail suppliers of the IPs, of the chips, of the SoC templates, whatever?
Yeah.
Yes.
Great. Yeah, good question. So probably a better question for the CEO, who's sitting right here, than the chairman. But look, I think exactly how these things will develop in terms of ecosystem, what will be part of a company, what will be in the open. I think that will evolve. And companies do change over time, right? We thought we had no chance at selling CPU cores to these big companies, and if you go talk to Naveed, you'll realize we actually succeeded. So we changed our plans. We now do sell to these big companies. But Naveed's right here, and that's probably a better question for him. All right, we got
Thank
10
you.
seconds. One more question.
The revolution of open source started with the GCC compiler. When you want to do a chip, then Cadence and Synopsys own the EDA tool market. So how do you see the role of open source EDA tools in that journey?
Great question. Art and Lip-Bu are friends, right? But I do think there's a totally different business model that needs to happen to produce SoCs. I'm very excited about the CHIPS Alliance in that context as well. I think at the end of the day, what the value is, mass customization at scale. You can't do that if your tools are stuck in the old business model. Every incumbent has a choice of how they want to deal with that, and I think we'll see how that goes.